switch on the left, please. Okay. Multiplication of complex numbers. 2 plus 3 iota times 4 minus iota. To multiply them out, well, it's twice 4 minus iota and 3 iota times 4 minus iota. 2 4s are 8, and 2 by that minus 2 iota. Plus 3 iota by 4, 12 iota, and 3 iota by minus iota, minus 3 iota squared. That's 8. Minus 2 iota plus 12 iota is 10 iota. I know iota squared is minus 1. So that's minus 3 times what? Minus 1, which is 3. 8, 9, 10, 11 plus 10 iota. Right? That's the multiplication. What about complex conjugates? Well, complex conjugates, if one is 2 plus 3 iota, its complex conjugate is 2 minus 3 iota. If that is z, well then this is known as z bar. Yes? And the only difference between a complex number and its conjugate is the sign in front of the iotas. To multiply them out, it's twice 2 minus 3 iota and 3 iota times 2 minus 3 iota. 2 by 2 is 4 and 2 by minus 3 iota, and that by that is plus 6 iota, and that by that is minus 9 iota squared. They cancel, and that becomes 4. Minus 9 iota squared plus 9, it becomes 13, which is a real number. Just to prove it, if z is equal to a plus b iota, what would its complex conjugate be? A minus b iota. And what happens if you multiply z by its complex conjugate? Well, it becomes a plus b iota times a minus b iota. And to multiply that, it's a by a minus b iota plus b iota times a minus b iota. A by a is a squared. A by minus b iota is minus ab iota. That by that is plus ab iota. And that by that is minus b squared iota squared. What's iota squared? Minus 1. They cancel. So I'm left with a squared plus b squared. And that is a real number. How do I know it's a real number? There's no iotas in it. So if I had 2 plus 6 iota, minus 2 plus 6 iota, by its complex conjugate, minus 2 minus 6 iota. I know the answer to that is minus 2 to be squared plus 6 to be squared, which is 4 plus 36, it is 40. How do I know that? Well, those two numbers are what? Complex conjugate. So that's how we multiply them. But again, we saw that the last day. We didn't do the division the last day. Division. If I had 2 plus 3 iota divided by 1 plus iota, how we divide them is we make the denominator a real number. So what would I have to do to 1 plus iota to make it real? No? Did someone say square? Did they? Yes. No, that won't make it real. What do I have to multiply by to make it real? By its complex conjugate. So that's 2 plus 3 iota over 1 plus iota by 1 minus iota over 1 minus iota. So I've done the same thing to the top and bottom. So what does that do with the fraction? It keeps it the same. It's an unchanged fraction. But now when I multiply out the top line, I have twice 1 minus iota and 3 iota times 1 minus iota. All over the bottom, once 1 minus iota and iota times 1 minus iota. I know the bottom is going to give me 2 anyhow, but just to show you the answer. Twice that, 2 minus 2 iota, and 3 iota times that, 3 iota minus 3 iota squared. All over the bottom, 1 minus iota plus iota minus iota squared. Minus iota, 3 iota squared, what's that? And 2, 5 plus iota. All over the bottom, 2. So we say that's 5 over 2 plus 1/2 I. And that's how we divide complex numbers. You have to divide 2 into both of them. Yes? Okay. If I had 2 plus 11 iota all over 2 plus iota, what we say is we rationalize the denominator. In other words, we make the denominator into a real number. That's 2 plus 11 iota over 2 plus iota multiplied by 2 minus iota over 2 minus iota. Multiplying out the top, it's twice 2 minus iota plus 11 iota times 2 minus iota. And the bottom, it's twice 2 minus iota plus iota times 2 minus iota. I know when I multiply out the bottom, I'm going to get 5, yes, because I'll get 2 squared and 1 squared. Multiplying out the top, 4 minus 2 iota plus 22 iota minus 11 iota squared. And on the bottom, 4 minus 2 iota plus 2 iota minus iota to be squared. That becomes plus 11. And 5, 15 plus 20 iota. Over the bottom, 5. So it will divide in, leaving me 3 plus 4 iota. So do you understand the procedure now of dividing complex numbers? Yes? What would you say the rule is? Well, you multiply above and below by what? The complex conjugate of the denominator. That's the same thing as that you rationalize the denominator. In other words, you make the denominator into a real number. Yes? Is that alright? Do you understand both of those procedures? Alright? Okay, that's your first note. Make a quick note of that.